Two heterozygous parents for cystic fibrosis are planning on having a child. Complete the genetic diagram and predict the probability of their child having cystic fibrosis. Use the letter C to represent the normal dominant allele, and use the letter little c to represent the recessive cystic fibrosis allele for 3 marks. So the first thing we need to do when working out a genetic cross using a Punnett square is to work out what the mother's and the father's gametes are. It tells you in the question that there are two heterozygous parents. So that means that the gametes of the mother and the gametes of the father are the same. They're both heterozygous. And we know that heterozygous means that they have two different alleles. So that means that they'll both have one copy of the dominant, capital C, and one copy of the little recessive allele, the little c. So you can fill in A as capital C, B as little c, so the dominant allele and the recessive allele, and then for C and D you want a capital C and then a little c, again the dominant and the recessive allele as another heterozygous parent. Then we can complete the cross. So E should be capital C, as we're getting one from a capital C from A and a capital C from C. And then F should be capital C and a little c. So we're getting a capital C from the father and a recessive allele from the mother. G should again be heterozygous, so a capital C and a little c. We're getting a capital C from the mother and a recessive allele from the father. And then finally, H should be homozygous recessive. We're getting two copies of the recessive allele from both the mother and the father. Once we've completed the cross, we can look at the probability of having cystic fibrosis. We know that the capital C, the dominant allele, is the normal allele, whereas the recessive allele, the little c, is the cystic fibrosis allele. We know that for a recessive allele to be expressed in the phenotype, it must be present as two copies, so the person must be homozygous recessive. This means that E, so capital C, they don't have cystic fibrosis at all because they are homozygous dominant. We know that F and G, who are CC, so they are heterozygous, they will be carriers of cystic fibrosis, but they won't have it themselves. So they can pass it on to their children, like the mother and father can, but they won't have it themselves. H is the only homozygous recessive outcome, so they will have cystic fibrosis. Therefore, 1 in 4 of the potential offspring will have cystic fibrosis. This means that there is a 25% chance that any child they have will have cystic fibrosis.